All right. So I just wanted to make a quick little informal video, not one of our highly produced ones we typically do with Petabridge, on a project I've been working on this week, which is getting Elastic APM support for Phobos. So I was able to go ahead and get everything successfully integrated by taking our existing Jaeger solution that we've been using to demo Phobos for a couple of years. And I was able to go ahead and reconfigure the Jaeger agent to route all of its spans through Elastic Cloud, which is something that they now support as of, I think, Elastic APM 7.5 or something like that. A pretty recent version. They only just added this feature earlier in 2021. And you can go ahead and see up here some of the documentation on how to go about doing this. So what we did to go ahead and make the sample work is we have a script inside this Kubernetes folder here called deployall.command. And this command expects you to pass in your own URL up to your Elastic Cloud APM instance or local instance if you want to use that, but then also your own APM bearer token. Now, if you're not using Elastic Cloud, you may not actually need this because you can go ahead and disable that type of agent authorization if you want. So you'll want to go ahead and modify the script potentially to do that. So that's our sort of deployment system. And then the way this whole integration between Jaeger and Elastic works in practice is we're installing a Jaeger agent, which is like a little sidecar container that takes all the trace data being produced by the client in my C# application, which has Akka.NET and Phobos running inside of it. And this agent pre-aggregates all those spans together, pre-correlates them, and then we'll go ahead and write them out in a protobuf format up to Elastic Cloud. And so we go ahead and we are mounting a couple of secrets from Kubernetes here that have our APM URI and our APM token. And I'm passing these in as arguments to the command line that the agent uses to connect to its Jaeger collector where the spans get reported. In this case, we're just using the plain old HTTP API that Elastic APM supports. That same API endpoint also supports the gRPC transport. Now you'll notice I've commented out this agent.tags tag here. This Elastic APM auth bearer token is how an agent authenticates with Elastic Cloud, but for reasons I don't fully understand yet, this does not get formatted correctly inside Jaeger, and so you get authorization errors when you're reporting up to Elastic Cloud. I went ahead and filed a bug with the Jaeger project about that, and I also let some people from Elastic know on their thread, but I'm not sure why that's happening. So what I did to work around that, and this works just fine, is I went ahead and I extracted my Elastic APM token into an environment variable here. And if I go back to my program.cs, let's see, actually, I think it's startup.cs right here. Yeah, here we go. I'm going to go ahead and configure Jaeger down here. I'm passing in my actor scope manager from Phobos, and I'm applying a global tag to all traces. And I'm passing in this Elastic APM auth tag here and the bearer token for my environment. And for some reason, even though the agent.tags property did not work, this does. And so our spans will be successfully uploaded when we deploy our Kubernetes cluster, which has a total of 3 pods that run Phobos plus an HTTP API and an Akka.NET cluster inside of it. We're also using Prometheus for metrics in the sample. This is because AppMetrics, which we currently target inside Phobos, doesn't have an Elastic integration right now. Elastic APM's drivers are all fairly new, probably within the past year and a half or so. And then on top of that, OpenTelemetry, which Phobos 2.0 is going to target. OpenTelemetry does have an exporter for Elastic, but certain types of metrics aren't supported, and the .NET OpenTelemetry SDK itself doesn't fully support the metrics spec yet because that's frozen, I think, now, but still not fully baked. So we're going to go ahead and wait until .NET 6 is released. At that rate, I think most of the details around OpenTelemetry metrics should be finalized, and we're going to go ahead and begin work on rebuilding Phobos around OpenTelemetry instead of using OpenTracing and AppMetrics.io. So that's kind of the direction that we're heading in. But in the meantime, this works great, and I'm actually very pleased with how the UI looks inside Elastic Cloud. So I'm taking a look at my services, and I see Petabridge Phobos Web. This is getting that service metadata from the Jaeger tracer itself. And I can go ahead and see some of my operations here. And I can see there's been a steady drumbeat of operations, averaging in the ballpark of 3.4 milliseconds end to end. That's pretty fast. We're just relying on Kubernetes readiness health check to go ahead and create a constant amount of load on this application. And it's going to generate one request every 5 seconds per node, roughly. So if I take a look here, you can go ahead and see our sort of latency distribution. And if I go ahead and take a look, actually, here's a real distribution with a bit of a histogram. I can go ahead and see some, let's say, errors that may have shown up inside our trace. And look at this. These are the operations that are being recorded via the open tracing middleware. I can go ahead and see, my host name, some data about the agent, and so on. But here's the operations I'm starting to record using a Phobos. This is actually a custom operation right here. So I went ahead and recorded this using just the tracer. But this is Phobos data. And so if I take a look here, you can see some labels I recorded, such as the type of message that we're trying to send via ask, the sender of this message, our service name, all that good stuff. So this trace right here represents the beginning of an ask operation. And you'll notice that most of the latency in this 4 milliseconds here consists of this ask operation being invoked. It gets awaited, and then after that await yields, we go ahead and wrap up these operations and serve the result back to end users. Now, this ask operation began with a string, and we were able to go ahead and send a string to this /user/forward actor running on this node. And I can see that the sender of this actor is the same temporary actor that was behind our ask operation. And I can see the type of actor that processed this message. All right, that all looks pretty good. If I go down here and I take a look at our metadata, I can go ahead and see that this is a /user/console actor, a different type of actor. And I wonder if, let's see, agent name, service name, span ID, stack trace, app. One of the things I was wondering a little bit about is if I can see on here, yeah, here you go. You can go ahead and see an actor getting spawned. You can go ahead and see basically the name of our full path of our actor system. Now, the one thing I'm not seeing, which we typically include inside all of our traces, and this is something that Jaeger does, not something that Phobos used to do, is you should usually be able to go ahead and see the host name for all the different instances here, since we have multiple versions of the service all talking to each other. For some reason, I don't see that in here. So I don't see the host name included. I might have to go and add that as a default trace. Now this is interesting right here, this little red loop. This is where we actually went ahead and we recorded a crash. And I can go ahead and see right here all of the relevant stack trace data when this actor threw that exception. And I can go ahead and see which node we're on. Yeah, there we go. So we're on Phobos Web 0. So that's one important piece of metadata included in there. And then if I go back to, let's see, go back to my little overview chart here, drill into this, take a look at, let's see, Phobos Web 0 is the name of the host here that started this operation. If I go ahead and take a look at, let's see, some of the other operations, I go into traces, hit refresh, drill down to this, take a look at our logs, no log messages to display. Let's see if I dig into here, transactions. I want to be able to go ahead and take a look. Here we go. Here's 276 samples. So I can go ahead and take a look at an earlier one. If I look at our metadata, we can see this happened on Phobos Web 2. So different node inside the node. So this is some of what we've been able to go ahead and capture just using this built-in integration with between Elastic and Jaeger. So we're going to go ahead and try to, of course, improve upon this, particularly when open telemetry is ready to go. That's going to be part of the next big sprint we're working on Phobos. But we're able to go ahead and correlate a tremendous amount of data about what's happening inside our actor system with virtually no decorator code at all. So if you take a look at our Akka service right here, You'll see I have this actor as one of the ones that throws exceptions that show up inside Elasticsearch. You'll see that I have my console actor as well. This console actor does record some custom operations using the Jaeger tracer right here. And then we have our router forwarder actor and an Akka.cluster router and a couple of the little bits of just some simple HTTP routes to process messages from. But otherwise, there's essentially no real instrumentation here. It's all being injected for us behind the scenes because of the way Phobos' configuration works, which if I go back to startup.cs, I can show you real briefly. We've registered an iTracer with Jaeger right here via our dependency injection system. This is the open tracing standard. And we've also gone and measured an app metrics, I believe it's called a metrics root. And we need both of those. Yeah, here we go, a metrics root and a tracer. We pass both of these into this little Phobos setup object, which basically binds Phobos to those objects that we're going to use for measuring what's happening inside our system and for tracing it. And then we go ahead and we combine that with, let's say, a bootstrap setup where we can pass in our HOCON configuration. And then this line of code right here, this Phobos provider selection.cluster, this basically changes the ActorRef provider from being the normal default Akka.cluster ActorRef provider to one that's being decorated with Phobos. And that is what allows Phobos to inject its telemetry behind the scenes into your actors without you needing to write a whole bunch of decorator code yourself. And most importantly, we wrap all the messages that are being sent between your actors, including messages that are going over the network. We wrap all those messages in correlation headers that allow those traces to all be tracked back to their original operation, which is why, if I take a look back through here, the only real, transaction we see, oh, look, I can see all three of my nodes right here. Perfect. But that's why the only real transactions we can see are this HTTP operation. And that's because every single trace originally begins with that operation. So that's what's going on there. So anyway, I hope you found this video helpful. Please let me know if there's any other Phobos questions I can help you answer. And thank you very much for your time. Appreciate it.